In this video, we're going to find some exact values of our 6 trigonometric functions using our double angle formulas. We're asked to find the exact value of all 6 trigonometric functions evaluated at the angle 2 times theta, given that sine of regular theta, the single angle, is equal to minus 2/3, and that single angle theta is in quadrant number 3. Well, if I just look at sine of 2 theta, I'm going to have to know both sine and cosine to use that double angle formula. So I'm going to start off by thinking about a reference triangle. So instead of the angle theta, which lives in quadrant 3, I'm going to imagine its reference angle theta bar. All right, well, sine is the opposite over the hypotenuse, ignoring the minus because in a right triangle, everything is positive. And now I can find this missing side. The Pythagorean theorem says the 3 squared is equal to a squared plus 2 squared. A squared equals 5. And that missing side has to be the square root of 5. So I know what cosine of theta is. Cosine of theta is minus root 5 over 3. Root 5 over 3 for my reference triangle, and a negative because my angle theta is down there in quadrant number 2. Well, now I'm ready to just go on and use these formulas and to see what happens. The sine of 2 theta is 2 times the sine of theta, minus 2/3. Times the cosine of theta minus root 5 over 3. Multiply all that together. 2 times that 2 is a 4 times root 5. Negative times negative is positive. And 3 times 3 is 9. So now I know the sine of 2 theta is 4 root 5 all over 9. All right, cosine of 2 theta. I could use any of these formulas I wanted to. But I'm going to use the one that only makes me use the sine of theta. They'll all give me the same value. And it's a good exercise for you to maybe go through after the video is over and try together formulas and see that you get the same thing. So why am I going to use that? Well, I know that's right. It was given to me in the problem. If I've made a mistake so far, it was right here. Now, I'm confident that's the right answer, but I always know what's printed is right. So I'm not going to use anything I don't have. I'm not going to use anything I've found that I don't have to. 1 minus 2 sine squared. Well, that's a minus 2/3 that's going to get squared. All right, well, it's going to be 1 minus 2 times 4/9. All right, so let's see. That's going to be 1 minus 8/9. Well, 1 minus 8/9 is 1/9. All right, I'm going to transfer some information over here to the second board. We found sine of 2 theta, to be 4 root 5 over 9. Cosine of 2 theta we found to be 1/9. And I guess I could use more addition formulas, double angle formulas, But instead, I'm going to use a quotient identity. I'm going to divide these two, so I get 4 root 5 over 1, which of course is just 4 roots of 5. And now I can just use my reciprocal identities. All right, so this is going to become a 1 over 4 root 5, a 9 over 1, and a 9 over 4 root 5. All right, I found all 6 of my trig functions evaluated at 2 theta. If we were sitting in a classroom together right now, I would ask you a question about where that angle 2 theta was living. I know theta was in quadrant number 3 from the original problem. But I'm wondering if you can look at this grid of values for all my trig functions evaluated at 2 times theta and piece together what quadrant 2 theta is in. I'm going to pause here and just count to like 3 or 4 in my head, and you yell a quadrant at your computer screen. I'm hoping you said quadrant number 1, because everything's positive here, and that just worked out in the finding the values of my identities, right? I didn't pick or choose that. That's what had to happen. Now, I hope you're also thinking to yourself, well, why is that true? Well, let's think about angle theta being in quadrant number 3. And I'm just going to think about the first revolution around the unit circle. And I'm going to think, well, if I'm thinking about that first revolution around the unit circle, I'd start at 180 degrees, right? And then I'd be rotating to 270. All right, well, if theta is between those two angles, 180 and 270, 2 times theta Well, let's see, that's going to be between 360 degrees, just multiply that by 2, and 540 degrees. All right, well, that is 360 degrees, start here, and 180 degrees more in there, so I'm either in quadrants 1 or 2, and these values tell me that that 2 times theta just had to end up in quadrant number 1. That's it for now.